Hello, everybody. Happy May. Um, we are continuing our lessons in the quadratics unit. Today we are going to do something called common factoring. Last lesson we were doing some expanding. Factoring is the opposite of expanding. So the goal for this lesson is to identify common factors and use them to write polynomials in factored form. Just in case you weren't sure, I have created a handout that goes with this lesson. So if you want to fill it out as we're going along, it looks something like this. It's called 4.5 Common Factoring Handout on Brightspace, and it looks like this. So if you want to fill it out as I go along, you can. After all the examples are done, the practice questions are at the end, and I will post answers for those. Okay, so let's go back to the lesson here. Okay, so you probably have identified common factors before. If you remember the term greatest common factor, that's what we're going to be using. Now, why are we doing this? Well, first of all, factoring is the opposite of expanding. And our goal is to be able to go from standard form to factored form. But we're not going to do this until next lesson. So we're going to back up a bit and just remind ourselves what greatest common factors are. So if we've done greatest common factors with numbers, that's the largest number that is a factor of two or more numbers. And I'm going to do some examples. And then if we add variables to our terms, the greatest common factor then becomes the largest factor that can go evenly into two or more terms. And I'm going to do examples of each of these so you can see what it looks like. So let's look at just um, straight up numbers. So you have done this before. So the question is find the greatest common factor of each set of terms. So we have 6 and 24. What you're looking for is what is the biggest number that can divide equally into both 6 and 24. Well, if you take a look at these, 6 can go into 6 as well as 24. So the greatest common factor for that one is 6. What about the second example? Well, 10 and 15. So what's the biggest number that can go into both these numbers? Well, you might notice they're both divisible by 5, and they're not divisible by any number bigger than 5. So the biggest number that can go into both 10 and 15 is 5. So the greatest common factor is 5. If we have three numbers, well, you still have to look at what's a number that can go into all three numbers and what is the biggest number that can. I always like to use the smallest number of the group to see if it can go into all of them. And so here, 6 can go into itself. It could also go into 12, and it can also go into 18. Anything bigger than 6 can't work because it has to be able to divide into 6 equally. So the greatest common factor is 6 there. Okay. So that's what we do with numbers. You have done that before in previous grades. Now we're going to throw in the idea of having letters or variables. So let's take a look at some examples. What are the greatest common factor for each set of terms? So here we have x squared and we have x to the fourth. Well, I know x squared can go into x to squared, or so it can go into itself, and x squared can also go into x to the fourth. So that means my greatest common factor must be x squared. What you're really doing when you're looking at terms that have exponents, you're looking for the term with the lowest exponent. So if I look here, I have an exponent of 2 and an exponent of 4. The lowest exponent is going to be x squared because anything with an exponent bigger than 2 cannot divide into x squared. But x squared can divide into anything above an exponent of 2. So let's look at B. You're looking for your lowest exponent. Well, we have a 2, a 5, and a 7. And if we don't have one, there is a little 1 there too. So the one with the lowest exponent is our x. So that has to be our greatest common factor because all these other ones cannot divide into x, but x can divide into the other ones. Okay, here's another example. We have x to the 3, x to the 4, and x. Again, you're just picking out the one with the lowest exponent. And so that's x again. So just here's a hint for this one. Look for the term with the lowest exponent. Example 3 is putting them together. So sometimes we have a constant and a variable in a term. So what are the greatest common factors for each set of these terms? So you know how to find the greatest common factor of a number set, and you just learned how to find the greatest common factor of the letter sets or the variables. Let's take a look here. We've got 6x and we've got 24. So your first step is looking at the numbers. So what is the greatest common factor of 6 and 24? Well, it's 6. And what about the letters? Well, this one has an X and this one doesn't, which means we cannot take an X out of either of these. So the only thing that can be divided out of each of these terms is 6. Okay. What about 10x squared and 15x? So first, look at your numbers. So 10 and 15, well, the greatest common factor there is going to be 5. 5 is the biggest number that can divide into both 10 and 15 equally. Now, we've got x squared here and x here. So you're going to pick out the x with the lowest exponent, and it's going to be part of the greatest common factor. So we had the number 5 and the letter x. And so our greatest common factor is 5x. Let's do one more here with 3 terms. We've got 6x cubed, 12x squared, and 18x. So for the numbers, you're going to find which number goes into all 6, 12, and 18. What is the biggest number that can do that? Well, it's 6 again. And then with your x terms, which one has the lowest exponent? Well, it's going to be x. So our greatest common factor is 6x. Okay, so this leads us to how do we take out a greatest common factor of an expression and how to write it in factored form. So here's an example. All we're doing now is we're putting adding and subtracting signs between the terms instead of commas. So the first thing you do is find your greatest common factor. So we've got 10 and 15. So our greatest number that can go into both those is 5. We have an x here, but we don't have one here. So our greatest common factor can't have an x in it because all of our terms don't have an x. So what you're going to do is you're going to divide each term by your greatest common factor. And you're going to show that by writing the greatest common factor out front. You're going to put a bracket and then divide each of these terms by 5 and write the results inside brackets. So 10x divided by 5, 10 divided by 5 is 2, and then your x is left over, so 2x. And then negative 15 divided by 5 is negative 3. You can check this answer by expanding. So remember the rainbow that we did last week? So if I do 5 times 2x, Oh, I don't know why that's not showing up. 5 times 2x is 10x, and 5 times negative 3 gives me negative 15 back. I'm not sure why that didn't show up. So let's try the second one. We've got negative 3x squared plus 12x. First, look at the numbers. What is the biggest number that can go into both of them? I'll take a negative 3 out just because I know 3 can go into both of these, but the first term has a negative, so might as well take it out. You don't necessarily have to. It'll just have a negative sign in the first term once you expand out. So we're going to take out negative 3. And then for our x terms, remember we're looking for the lowest exponent. So our greatest common factor is negative 3x. It could also be 3x, okay? But I like to think if there's a negative sign in front of the first term, I take it out with it, just so that it looks nicer. It's not wrong if you put 3x. So if I take out 3x out of all of these, if I divide negative 3x squared divided by negative 3x, then negatives 3 canceled. One of these x's will cancel with this x. So x squared divided by x leaves me with 1x. And then 12x divided by negative 3x, well, 12 divided by negative 3 is negative 4. And then if you have x divided by x, those are going to cancel out. So this is funny that it's happening down here. So if I expand this one, let me get that out of the way. If I expand this one, notice if I do negative 3x times x, I get negative 3x squared back. And if I do negative 3x times negative 4, I get positive 12x back. So that worked. Now let me guess it's going to show up. Oh, no, it didn't. Okay. So example 5, we're going to just do a little longer example. So now we have 3 terms in one equation, not just 2. So we're going to find the greatest common factor first, and then we're going to check by expanding. So what's the biggest number that can go into 4, 12, and 20? Well, I know 4 can go into 4, and that's the biggest number that can go into 4. And 4 can go into 12 as well as 20. So the number must be 4. Now let's look at our x's. I have an x squared and x and no x here, which means I cannot take an x out. So my greatest common factor is 4. So to write that in factored form, I'm going to put the 4 first and then write a bracket. And then I'm going to divide each of my 3 terms by 4 and write the leftovers in the brackets. So 4x squared divided by 4 leaves me with an x squared. 12x divided by 4 leaves me with 3 x's. And 20 divided by 4 is 5. So my factored form is 4 times x squared plus 3x plus 5. Okay. To expand this, if I do 4 times x squared, I get 4x squared. 4 times 3x is 12x, and 4 times 5 is 20. And so yes, those match. So that means I factored this right. I took the greatest common factor out correctly. So this form should look familiar to you. That is a standard form of a quadratic equation. So this is leading us into the next lesson and what to do with these leftover things to factor it. Okay, that's it for the lesson today. So I really want you to practice these. So if you go back to the 4.5 handout, you can complete the practice problems at the end. I have posted that handout filled out so you can see my written solutions. I have posted some extra practice questions on Knowledge Hook. So if you go to Knowledge Hook and go to the 4.5 mission, you can practice these types of problems. And finally, once you feel comfortable with that, you can try the 4.5 quiz on Brightspace. It is a multiple choice quiz, so fairly straightforward to take, no filling in the blanks on that one. Okay, that's it for this lesson. Please let me know if you have any questions. You can use the envelope in the top right-hand corner of Brightspace by either sending me a message or an email through there. Good luck with this lesson. Let me know if you have questions, and I will see you next time. Bye, guys.